In 1995, a 6.9 earthquake in Kobe destroyed 100,000 private homes built in the traditional style in only 20 seconds, leaving 300,000 people homeless and killing thousands. However, in the same quake, the taller pagodas remained standing. Although hundreds of years older and built using the same interlocking technique, they didn't collapse. Intrigued by the mystery, I wanted to know more. So I went to the pagoda at Kiyomizu Temple in Kyoto to meet an expert. Hidekazu Nishinzawa is Professor of Structural Engineering at Kyoto University. How does it work? He explained that while the flexibility of the interlocking technique increased the earthquake resistance, the more crucial component was inside. According to Professor Nishinzawa, earthquake resistance is a matter of movement and harmonics. Surprisingly, the secret turned out to be a central pillar. Unlike the one in Mr. Yasui's preserved house, this one didn't provide the central support, but stood like a huge telephone pole in the center of the pagoda. Incredibly, this vertical pillar was attached only to the first floor, but not to any of the walls. So that's the bottom of the pillar?
Yes.
So it's not actually at the bottom of the pagoda, it starts on the first floor?
Yes, at the top of the first floor.
Right.
And that will be rightly connected.
And then it's just floating up there. Look, it's moving.
Yes.
And how does that work? How does the pillar absorb all of that that force?
The vibration mode of the outer frame quite different from the center pillar.
I see. So it absorbs the force from the rest of the building and takes it inside.
Yes.
This is how it works. When the earth moves, the pagoda sways like a snake, leaning against the rigid central pillar, which then counters the movement of the outer structure and prevents it from toppling over. This is the secret to their earthquake resistance.
Slowly.
Can we move
it?
Oh, look at that. That's astonishing.
Yes.
Japan is known not only for massive earthquakes, but for towering skyscrapers. Tokyo especially is famous for them. I had heard that the pagoda design had found a new application there. Until 1968, height restrictions kept Tokyo's skyline well below the current scale. But then, Kiyoshi Muto built the Kasumigaseki building, the city's first skyscraper. Inspired by the pagoda, Mr. Muto designed his building to sway like a willow. Since Mr. Muto's time, many of the principles used in pagoda construction have been applied here in Tokyo's ever-growing forest of skyscrapers. With the earthquake resistance this gives them, only the sky is the limit. The ancient pagoda technology has been incorporated into the construction of one of Tokyo's newest skyscrapers. You can't tell from the outside, but I knew where to look. I met Mr. Tatsuo Inada, Head of Technology and Research for the construction company. He took me behind the scenes to show me the skyscraper's backbone. Mr. Inada pointed out that the central pillar concept had been directly adapted to the four pillars supporting this building. So this absorbs the force and then the force goes up the pillar?
Yes.
Four massive steel pillars form the flexible core of this 37-story skyscraper. Today's engineers modified the pagoda freestanding pillar concept. Using flexible steel plates, they connected the pillars to the building's superstructure. So that's what takes the shock. The model shows them as elastic strips that allow the building to sway when the earth moves. So far, no earthquake damage has been recorded. So it really works?
Yes.